trig identities. So I'm sure you remember these from National 5. Now at National 5 you either loved these and were really good at these, or you hated them and it just didn't make any sense. And I'm afraid at higher it just gets a little bit trickier. So if you didn't love them at National 5, the chances are you're still not going to be a fan of them. However, they are very rare in showing up, and they are only ever worth maybe 2, 3, 4 at a push marks. So that's not the be all and end all if you don't like these. So this first example on the left hand side wants you to prove that that expression on the left of the equal sign is equal to tan x. Now remember, when you're doing a proof, you only ever work with the left hand side and prove the right hand side. Don't work with both sides at the same time. Don't work from the right hand side and go backwards. Always start with this left hand side. So on the left hand side, we've got sine cubed x plus sine x cos squared x over cos x. So this is what we are working with. Now, if you're ever unsure, just try something, okay? So the first thing that I'm noticing about this is that we've got a sine cubed x plus sine x. So we've got a common factor of sine x on that top line. So if I take out a sine x, it's going to leave me with sine squared x plus cos squared x, in my brackets, all over cos x. I'm missing an x over here. When you've done that, this part here should hopefully stand out. So remember from National 5 that sine squared x plus cos squared x is equal to 1. So really what we've got here is sine x times by 1 over cos x. That would then just simplify obviously to sine x over cos x. And again, thinking back to National 5, the second trig proof that you learnt was that sine x over cos x is equal to tan x. So we've just proven that the left hand side equals the right hand side. So that's us completed that proof. Looking at this next one, so the next one starts to involve a little bit more higher skills. That last one involved quite a few things from National 5. So for this one, again, you're always starting on your left hand side. So you've got sine 3x. Now straight away that should stand out as being a little bit unusual to you because we tend not to work with sine 3x. We do, however, know this year about sine 2x. We've got double angle formulas, we've got addition formulas, we've got a variety of different things that are hopefully coming to mind. So sine 3x is going to be the same as sine 2x plus x. Now the reason that I've done that is because I know that we're more familiar with the 2x, but then when we've got this 2x plus x, hopefully we're recognising that this is going to be one of your addition formulas. So if I continue from there, sine 2x plus x is the same as sine 2x cos x plus cos 2x sine x. Now both of these have got a double angle formula. We've got a sine 2x and we've got a cos 2x. So next thing I'm going to do is replace these. So over here, I'm going to have 2 sine x cos x, and we've still got that cos x to the right. And then we're adding on, so at this point here, you've got a variety of different options, okay? Now, because I'm thinking a little bit further ahead, and the fact that I've got 2 cos x's here, and that's going to give me a cos squared x, I'm going to assume that I'm going to be able to get to the point where I can get rid of that cos squared x. So I'm going to choose the expansion 1 minus 2 sine squared x for my cos 2x. So 1 minus 2 sine squared x, sorry, trying to squeeze this all in, times by sine x. Now, noticing things like that will come with practice. Right, so if you just keep practicing, you will get quite familiar with them. You'll notice that it's the same tricks over and over and over. So my next line, I'm going to tidy up by multiplying out my brackets. So I've got a 2 sine x, then as I said, this is going to give me a cos squared x, plus, so multiplying this bracket out, I've got 1 times sine x gives me sine x, minus 2 times sine squared x gives us sine cubed x. Now looking at the start, looking at the question, the right hand side, that sine cubed x is a good sign that we're going in the right direction. Okay, so now we need to keep going from there. So the next thing I'm going to do is get rid of that cos squared x. So think back to National 5. If sine squared x plus cos squared x gave you 1, then that cos squared x must be equal to 1 minus sine squared x. And I've still got this plus sine x minus 2 sine cubed x. Again, I've got brackets, so I'm going to multiply my brackets out. So 2 sine x minus 2 sine cubed x. So there's another sine cubed x. Plus sine x minus 2 sine cubed x. I'm now going to tidy it up. So I've got a 2 sine x and a plus sine x. So that gives me 3 sine x in total. A negative 2 sine cubed x and another negative 2 sine cubed x. So that's going to give me minus 4 sine cubed x. And if I compare that back to what we were looking for, I've now got this minus 4 sine cubed x and we've got the 3 sine x. So that's us completed because our left hand side is equal to our right hand side.